Hello and welcome to our mathematics lesson today. We are continuing to look at the topic on quadratic expressions and algebraic fractions. During our past lessons, we were able to look at accumulation of events that led us to the identification of the quadratic identities, where we did mention of three basic quadratic identities that you should be aware of, so that whenever you want to expand or whenever you want to factorize algebraic expressions, then it's going to be much easier for you. The three quadratic identities were as follows. Number one, we talked of the additive quadratic identity. That is when you have a plus b raised to 2. This is a quadratic expression. Whenever you expand this, the identity led us to the discovery that this, when expanded, shall be a squared plus twice this the product of the two figures or item twice ab plus the square of the second term. That is the first quadratic identity. The second quadratic identity was when the sign here changes to be negative, so that we have a subtract b, the whole of it raised to 2. So during expansion of such a quadratic expression, we identified or we discovered that everything is going to remain as we have there, but the first sign is going to be negative. So when expanded, this shall be a squared, subtract twice the product of the two terms plus the square of the last term. The third quadratic identity, we did mention that it's a difference of two squares, so that when you have a plus b multiplied by a minus b and you want to expand it, and it can be vice versa, you can have a minus b followed by a plus b, then this is going to be a difference of two squares, in that we are going to have the first term squared subtract the square of the second term. So these are the three quadratic identities that were built up of our previous lesson. So today we want to look at two subtopics in this particular topic. We are going to look at how you can be able to factorize by simply grouping, and then we look at how you can be able to factorize monic quadratic trinomials. So whenever the question of factorization by grouping comes into question, then that means we are going to group some particular terms. The terms which we are going to particularly group are what we normally refer to as like terms. In most cases, quadratic identities can be of the form x squared plus 2 plus 2x subtract ax minus m. As you can be able to see, this particular quadratic expression, we can be able to group them into two pairs depending on the like terms which are contained in each of the two expressions. Like in this case, the reason why we are pairing this is because we have got x being common. The reason why we are pairing this together is because we have got a, which is common. Then you now move ahead and do the factorization of each one of them independently. So whenever you want to factorize by grouping, there's some steps that you should be able to follow. So we're saying that factorization by grouping can be used whenever we have a four-termed expression. Let's look at the step-by-step process in which you can be able to use to do a factorization of a four-termed expression. Let me use x squared plus 3x subtract bx minus 3b. The first step is the terms are grouped into pairs. You first group the terms into pairs and factorize separately. Now in this particular case, you can be able to see that there's x, there's b, there's b. So you can be able to first pair up these terms. Pairing means you put them into 2, 2. Then you factorize each independently. So when you factorize this bracket, you'll discover that x is common. So this will be x plus 3. Subtract. On the other bracket, b is common. B, negative b goes into bx x time. Then negative and negative, this will give us positive. B goes into 3b 3 times. So that is the first step. Number 2, the common binomial, as you can be able to see that there is a common term. We refer to it as the common binomial factor. So the common binomial factor is then taken out to complete factorization. So we are saying that we take out the binomial common factor, which is x plus 3. So this will give us x plus 3. We are taking it out into x subtract b. And there we will have completed the factorizations. Last step, you can do the rearrangements. We can begin with x minus b followed by x plus 3 with whichever you will be comfortable with. So terms can be rearranged. You can rearrange the terms to assist in the search for a common factor. Like for instance, if we had the swapping of 3x with 3b, then you'll discover that you cannot be able to proceed with such a particular expression without rearranging it. So you can first rearrange before you proceed into factorization. So these 2 steps, the first and the second one, are very critical. Number 1, we have said that you group the terms into pairs and then factorize them separately. Then you take the common binomial factor out and complete the factorization process. Then we are saying you can always rearrange the terms inside your expression for easier search of the common factor. We now want to consider a number of examples on which we can be on how we can be able to solve or factorize by simply grouping. Example 1, use the method of grouping to factorize these expressions. Number 1, we are given x squared plus 2x plus ax plus 2a. Part B, we are given xa plus 3a minus 5x minus 15. So we want to solve these two or factorize them by simply grouping. We had said that in the grouping, factorization by grouping involves two critical steps. One is pairing them or the terms, and then two is identifying the binomial common factor. In the first case, we are having x squared plus 2x plus ax plus 2m. So we can be able to pair them comfortably because each of them will have a common factor. Then we move on and factorize each of them independently. So when we factorize the first bracket, you'll discover that x is common. So that will be x goes into x squared x times plus x goes into 2x twice, then plus a is common in this case. So we have a into a goes into ax x times plus a goes into 2a 2 times. So you'll discover that we have a common binomial factor, which is x plus 2. And the second step in factorization by grouping says that we now take out that binomial common factor, which will be x plus 2 into x plus 2 goes into the whole of this x times plus x plus 2 goes into the whole of that a times. And this will now be our resulting answer. For part B, we are given xa plus 3a minus 5x minus 15. Again, we can be able to comfortably pair them into pairs of 2, 2, since each of the two brackets are going to have their own common factor. In the first case, you can be able to see that a is common, so we factor out a. So this will be a into a goes into xa x times plus a goes into 3a 3 times. Subtract. Between 5x and 15, 5 is common. So we factor out 5. 5 goes into 5x x times. Negative 5 goes into negative 15, positive 3 times. So again, you discover we have a common binomial factor, which is x plus 3. We now move to the second step where we now take it out. So when it is taken out, we shall have x plus 3 into now the remaining, which will be a minus 5. So that is how we can be able to simply factorize by grouping. Let us look at a case where you need to first do the rearrangement. Factorize, example 2, 2xa subtract 9 subtract 18a add x using grouping. We now want to solve this particular equation by using grouping. So when you say that you want to use grouping, you'll discover that if you say you group this and this one, then you are not going to obtain like terms. In the first case, we have 2xa, this is 9, so there is no common term. 18a plus x, there is no common term. So this will take us to the third step in the solution of quadratic problems using grouping. And that means we must first do the rearrangement of our terms so that we can easily be able to identify a factor. Now when we rearrange, we should be particular so that in that case while we are arranging, we can be able to find terms that are common. So like in this case, we can be able to attach this term and this term, then this term and that term. So that will give us 2xa plus x minus 9 minus 18a. Or you can attach this and this because you have a and a, then you attach this and that. So long as it is going to give you pairs which can easily identify a common term. So from here we now group them into pairs of 2, 2. After grouping them into pairs of 2, 2, we go to the second, we factorize each of them independently. The common factor in 2xa and x is x. X goes into the whole of that twice a times, plus x goes into x once. Then we have subtraction there. You can be able to see, so we're going to pick the factor there to be 9. So this will be 9. Into 9 goes into 9 once, plus 9 goes into 18a twice a. So if you look at what you have in the brackets are equally the same, you can be able to write this beginning with 1, or you can write this beginning with 2a. So this will be 2a plus 1 minus 9 into 2a plus 1. So you discover that we have a common binomial factor, which you can now finally take it out into x subtract 9. So this case requires us to extensively use the third procedure, and that is doing the rearrangement. And then whenever you are doing the rearrangement, you should be sure, or you ensure that you're going to have factors which are going to be common. Let's take the other point of view. If we said that we now combine 2a and 18a, so we shall have 2xa minus 18a minus 9 plus x. That is another way in which we could have rearranged this particular expression. So we now group them into pairs of 2. The common term here is going to be 2a. And this means we are going to have 2a into 2a goes into 2xa, x times, subtract. 2a goes into 18a 9 times, subtract. A common factor here is 1. So this is going to be 1 goes into 9, 1, then 1 goes into, this is 9, 1 goes into x times, x times. So we can be able to rearrange that so that we have a common factor. So this will be 2 into x minus 9. Let us change this particular point so that inside the bracket we begin with a positive x. So this will be plus 1 into, we now rearrange because that will be negative 9 plus x. So when you do the swapping, this will be x subtract 9. So we finally end up with a pair of binomial factor, which we can be able to take it out. And this will be x minus a into 2a plus 1, which is much or less than what we already have here, only that we are having the flicking of the 2. Example 3. Use the method of grouping to factorize the following expressions. 1, we have x squared plus 3x plus ax plus 3a. Number B, we have got 2xy minus 8xz plus 3wy subtract 12wz. So I want to solve these two by grouping. So when you look at this first expression, you can easily be able to identify or see that if you just group them into two pairs of 2 each, you will discover that each of them is going to have a common factor. So you can simply go ahead and do the grouping. So after grouping, you can factorize each of them independently. The common factor between x squared and 3x is going to be x. X goes into x squared x times plus x goes into 3x 3 times plus common factor between ax and 3a is a. A goes into ax x times, a goes into 3a 3 times. So you again discover we have a bimodal common factor, which is x plus 3. We take it out so that x plus 3 goes into x plus 3, x times x times plus x plus 3 goes into x plus 3 a times, and that will be the factorized form, x plus 3 x plus a. In the second question or expression, we have got 2xy minus 8xz plus 3wy subtract 12wz. So again, this one we can easily be able to pair them because we are going to have a pair or like terms or a common factor in each of the pairs. You can be able to see that between 2 and 8, 2 is going to be common, multiplied by another common, which is x, because it's common on the 2. Now 2x goes into 2xy, y times, subtract. 2x goes into 8xz, 4 times z, plus common between 3wy and negative 12wz is going to be 3w. So we're going to have 3w into 3w goes into 3wy, y times, subtract. 3w goes into 12wz, 4z times. And therefore you discover that whatever you have inside the brackets are the bimodal common factors, which we can be able to take them out, and we shall have 2x plus 3w. So that is how you can be able to factorize by grouping. Let's consider a final example. Example 4, factorize the expressions by first rearranging the terms. Number 1, we have 3b plus 4a plus ab plus 12. Then part B of the equation, we have 5x plus 2y plus xy plus 10. So let us solve these two by grouping, but we first rearrange the terms so that we can easily be able to identify the common factor. As you can be able to see, if you say that you pair this and this, then there shall be no common factor. So we need to do the rearrangement. And in the rearrangement, this can go with that, or it can go with 12. So we can pick it to go with AB. So 3B plus AB plus now the remaining, which is 4A plus 12. Then we now pair them into pairs of 2 each before finally moving in to factorize each of them independently. So a common factor between 3B and AB is B. B goes into 3B, B goes into 3B 3 times, B goes into AB A times, plus a common factor here is going to be a number which is 4. 4 goes into A times, 4 goes into 12 3 times. As you can be able to see, we have 3 plus A, we have A plus 3. So you can swap either to match. We're going to have B into 3 plus A plus 4 into 3 plus A, because the order whenever you're adding doesn't matter. So at this stage, we now have a common bimodal factor, which we can now be able to take it out. So 3 plus A into B plus 4. So this will be the factorization of this particular expression by grouping. Part B, we are having 5x plus 2y plus xy plus 10. Again, at this stage, you can take 5x to go with xy, or to even go with 10, because you're going to have a common factor between the two. So that 2y is factored out with x plus y or 10, whichever. So in this case, during the rearrangement, we're going to have 5x plus xy plus 2y plus 10. Then we now move in and pair them into two terms each. Then we finally do the factorization of each bracket independently. So when the common factor between 5x and xy is x, so you're going to have x into, x goes into 5x 5 times, plus x goes into xy y times, plus you can be able to see that the common factor there is going to be a number, which is 2. 2 goes into 2y y times, 2 goes into 10 5 times. Again, you can be able to see that 5 plus y and y plus 5 are equally the same. You can begin all of them with 5. 2 into 5 plus y. So that we now take out the common bimodal, which will be 5 plus y into x plus the 2. So that is, in a nutshell, how you can be able to solve quadratic expressions by grouping. So whenever you want to factorize, those are the critical steps that should be followed. 1, pair them into 2, then factorize each of the brackets independently. Then number 2, you take out the bimodal the bimodal common factor between the two. And then finally, in case like in this example where we are having a mix-up of the expression or the terms, then you are allowed to do the rearrangement so that you are easily able to take out the factors. We now want to look at another subtopic on the same, and that is how we can be able to factorize monic quadratic trinomials. Now, trinomials, that means it has got 3 terms inside that particular expression. Then monic can be derived from the term mono, which is 1. So that means that the coefficient of the first term must be 1. So an expression of the form x squared plus bx plus c, where b and c are constants, will be referred to being a monic quadratic trinomial. One, it has three terms, then the coefficient of the first term or the highest power of x should be 1. So in this particular case, then we refer to it as being a monic quadratic trinomial. But in case it had a different number like 2, 3, 4, then it ceases to be a monic quadratic trinomials. It becomes an non-monic quadratic trinomials. So during this lesson, we want to look at how we can be able to factorize monic quadratic trinomials. Then during our next lesson, we'll look at how we can be able to do the same for non-monic quadratic trinomials. So in this case, we are saying that an expression of the form x squared plus bx plus c, where the terms b and c are constants, where the two terms a and b are constants, is a good example of monic quadratic trinomials. Now there's a critical procedure that is normally followed whenever you want to factorize monic quadratic trinomials. We're going to look at each step by step. Now we are saying that to factorize quadratic trinomials of the form x squared plus bx plus c, here are the steps. 1, multiply to give c, multiply to give a term c, that is the c, then 2, add so we're saying that whenever we want to factorize quadratic trinomials of the form this one, we first find two terms. In fact, they are called, in most cases, these are numbers. In that, when multiplied, the result will give you a c. And when you add or get the sum of those two numbers, then you get b. Add to give b. So we're going to use an example of x squared, subtract 3x, subtract 10. So this negative 3 is going to be your b, negative 10 is going to be your c. So the step here, or the critical step, is that we must find two numbers in that when you multiply the two numbers, they'll give you a c. And if you add the two numbers, you'll get a b. Now in this particular case, when we take which numbers can be able to give us negative 10 when multiplied and negative 3 when added. So we think of the two numbers. and you can be able to combine as many times as possible. The two possible numbers that can give us negative 10 when multiplied and negative 3 when added is negative 5 and positive 2. So when you take negative 5 by positive 2, the result will be a C, which is negative 10. And when you take negative 5 plus 2, the result will be negative 3, which is a B. So you do the combination of those particular numbers until you find them. After finding those numbers, what next? So we now use an expansion, or we rewrite our expression where there is B, we insert in the two numbers that we have found out. Then next we use expansion to check. We use expansion to check your factorization if it is right. And then lastly, rearrangements in your answer or answers is allowed, so that if you had x minus 5, x plus 2, or you begin with either x plus 2, x minus 5, it's going to be allowed. So after you have gotten the two factors or the two numbers, which if you multiply they give you negative 10, and if you add they give you negative 3, you now go ahead and insert the values of x on each. Like in this side, you put their x, on this side you put their x, then you put them in those separate brackets, and this will be x subtract 5 into x plus 2, and you can always interchange. Now there are situations whenever C is negative, then that will tell you that your two numbers, one of them must be positive. When C is positive, then it can either go two ways. One, the two numbers can all be positive, or the two numbers can all be negative, because you understand that whenever you multiply negative numbers, two negative numbers, the result will be a positive number. So that is what they go by, and that's what we want to look at. So if C is a negative number, whenever C is a negative number, the sign in the factorized expression will be different from each other. Example given is when we had x squared plus 5x subtract 6. So you can be able to see this is our b, that is 5, and this is our c, which is negative 6. So it is negative in number. It's a negative number. That tells us that the two factors are going to be of different signs. Now in this case, we look for a term which when we multiply we get negative 6, and when we add we get positive 5. This will tell you that the two numbers which when multiplied give you 6 and when added they give you 5 is going to be 6 and 1. 1 will be negative, 6 is going to be positive. So you can be able to see that the two numbers are of different signs, and therefore in the factorized expression we shall have x plus 6 and x subtract 1. What if c is positive? Now when c is positive, I said earlier that it can either go two ways. The signs in the factorized form will be the same as each other. Same in the sense that both of them are either going to be positive or both of them are going to be negative. Example given, if you have x squared plus 5x plus 6, this is your b, it is a positive number. This is your c, it's a positive number. So this tells us that whatever we're going to have inside the bracket is going to be, all of them are going to be positive in the factorized form or the factorized nature. Now in this particular case, the two numbers which when multiplied will give you positive 6 and when added will give you positive 5. It's going to be positive 6 and positive 1. So again you discover that the two numbers are all positive. What if this was, let's finish this. So in this particular case, whenever you want to expand or you have to have this expression in a factorized form, then what will be inside the bracket, all of them are going to be positive or they are going to be having the same sign. If they are negative, then both of them are going to have negative signs. So C is positive, signs are the same. So we now want to look at a number of examples on how we can be able to factorize monic, quadratic trinomials. Example 1. We are told to factorize each of the following. Each of the following quadratic expressions. Number 1, we have x squared plus 7x plus 10. Number B, we have x squared plus 2x subtract 8. Number C, x squared subtract 7x plus 10. So I want to solve these three questions. The first one is x squared plus 7x plus 10. So we had said that in the first step we need to identify or look for two numbers which when multiplied will give us a c. And this particular case our c is positive 10, our b is positive 7. So we need to look for two numbers such that when multiplied we're going to have 10, which is a c, and when added it's going to give us a positive 7, which is a b. Now when you look at this critically, you'll discover that the two numbers are positive 5 and positive 2. So when you take positive 5 multiplied by positive 2, you'll get positive 10. And when you take positive 5 plus positive 2, you'll get positive 7, which is the value of b. So in that case, those are the two numbers. So we now rewrite them in brackets, and this is going to be x plus 2, x plus 5. And these two can also be rearranged so that you have x plus 5 into x plus 2. So the most critical step for Monic quadratic trinomials is for you to be able to identify the two factors which when multiplied give you a c and when added gives you a b. And as you can be able to see, our c was positive, the signs remained the same, or the signs inside the brackets remain the same. In part b, we have x squared plus 2x subtract 8. Now in this particular case, you can be able to see that our c is a negative number and our b is 2. So we need to look for a pair or for two factors such that when multiplied they are going to give us negative 8, and when added it's going to give us positive 2. So you'll discover that these two numbers are positive 4 and negative 2. So that when multiplied, negative 4 multiplied by negative 2, it will give you negative 8. And when you add negative 4 plus negative 2, the result will be a b, which is 2. So we now write those into brackets. This will be x plus 4 into x subtract 2. And you can also interchange so that we have x subtract 2 into x plus 4. So these two are the same. Example 2, we are told factorize the quadratic expression. We have 2x squared minus 2x subtract 12. Now, if you're very keen, we had said that Monic quadratic expressions are always of the form x squared plus bx plus c, where the first highest power of x, or the first term, has no coefficient. But if you look at this expression initially, this cannot be a Monic expression because 2 is not 1, or the highest power of x has a coefficient which is 2. In this case, then we shall be required to make it Monic. And these are good expressions because they can easily be converted into Monic by simply dividing through by the coefficient of x squared, which is 2. So 2x squared subtract 2x subtract 12, we divide through by 2. You cannot divide through by 2, but you can factor out 2. So this will be 2 into x squared subtract x subtract 12. You can now be able to see that after factoring out 2, which was common on the 3 terms, we now have a Monic expression. We can now proceed and now get or factorize this Monic expression, which is x squared plus x subtract 2 goes into 12 6 times. Now our b is going to be negative 1, while our c is going to be negative 6. We look for two numbers which multiplied are going to give us negative 6, and when added it's going to give us negative 1. What are these two numbers? You'll discover that these two numbers are going to be positive 2 and negative 3. When you multiply these two numbers, the result will be negative 6. When you add these two numbers, the result will be negative 1. So this will be 2 into whatever we shall be having here shall be x plus 2, x subtract 3. And we can be able to say that this is now a factorized form of that particular quadratic expression. So important is first make it to be a monic expression by taking out the common term between the three given expressions. Now example 3, we are told factorize each of the following quadratic expressions. Number 1, we have x squared plus 3x plus 2. Part B, we have x squared plus 10x plus 16. So I want to solve these two, and as you can be able to see, these are monic quadratic trinomials because the coefficient of the highest power of x is 1. And in this particular case, we need to look for two numbers which when multiplied they are going to give us the c, which is 2, and when added it's going to give us a b, which is 3. Now which are these two numbers that when multiplied the result will be positive 2, and when you add these two numbers the result will be a 3? You'll discover that these two numbers are going to be positive 2 and positive 1. So we simply put them into bracket beginning with x, so this will be x plus 2. This one will be another one, that is x plus 1 into another bracket. So it's quite or as easy as that. For part B, we have x squared plus 10x plus 16. This will tell you that our c is positive 16 while our b is positive 10. We now need to look for two numbers such that when multiplied these numbers will give us 16, and when added we are going to get 10. So what could these two numbers be? When added we have 16, when multiplied we have 16, and when added we have 10. So for us to have 16, you can have a combination of several numbers. We can have 4 by 4, we can have 8 by 2, we can have 2 by 8, and so on. But when you add 4 plus 4, you will get 8, not 10. What if when you add 8 and 2, the result will be 10? So this tells us that the factors or the two factors are positive 8 and positive 2. And therefore we are going to have them being positive 8 and positive 2. So when we rewrite them in factorized form, this will be x plus 8, again x subtract 2. We now want to consider a last example on how we can be able to solve monic quadratic expression. Make it example 4. Part 1, we have 2x squared plus 10x plus 8. Then number 2, we have 3x squared subtract 3x subtract 36. As you can be able to see, these two expressions, they are not monic. We must make them monic by factoring out a common term. So when in the first expression we're going to factor out 2, so this will be 2 into x squared plus 5x plus 4. This one is now a monic expression, which we can now proceed to factorize. This is going to be our b, and this is going to be our c. So two numbers, when you multiply them, they give you 4, and when added, they give you 5. Those will be positive 4 and positive 1. So that means that inside the bracket, we're going to have x plus the first one, which is 4, open the bracket, x plus 1. And you discover that the powers, the signs are going to be the same, that is positive, simply because there was a positive c. With part c, we need to factor out 3, and this will give us 3 into x squared minus x minus 3 goes into 36 12 times. We therefore need to factorize that, which is now a monic expression. And in this particular case, we need to look for two numbers so that when multiplied, the result will be negative 12, and when added, the result will be negative 1. So in this particular case, the two numbers will be negative 4 and positive 3. And this will give us 3 into x subtract 4, x plus 3. All of that multiplied by 3. So this brings us to the end of our discussion, where we have been able to look at the two subtopics. 1, on how we can be able to factorize by grouping, and 2, how we can be able to factorize monic quadratic trinomials. When we meet next, we shall look at how we can be able to factorize non-monic quadratic trinomials. Thank you.